Hey folks, I thought it was worth a real quick note here regarding the integrals as a net change to kind of put it in maybe context or give you another thing to think about here. We've looked at this integrating sine x of this definite integral as just finding the signed area. And we've done this a lot of times. I think, we've gotten that it was 2 in our calculator, but we can also now, because we know the fundamental theorem, we can do this by hand. So this is what the graph for finding the area of the graph of sine x on 0 to pi looks like. And when we actually find it, it involves finding the antiderivative of sine. So look at what did we take the derivative to get sine? And then plug in the upper bound. So we'd have negative cosine pi minus negative cosine 0. And cosine pi is -1, so negative 1 would be 1. And then we've got, this is plus, and cosine at 0 is 1, so we're getting 2. And I think that might jar your memory here. Okay, here's the issue I wanted to hit home. We've done this problem numerous times in different videos, but this is what the cosine graph looks like on 0 to pi. Okay, let's look at the cosine graph. Sorry, the negative cosine graph. The negative cosine graph on 0 to pi looks like this, because it's our cosine graph, but it's been flipped over. And I want you to look at what I mean by net change. We started at a y value of -1, and the cosine over here at the end of the interval ends up at +1. This is a net change of +2. Okay, the y, that's what this means, this idea of this net change. Okay, and then we can try this one too. If I graph the cosine x, and this is the positive cosine x, we can see that this area is probably going to be 0, but let's go ahead and verify it using the fundamental theorem. Antiderivative of cosine is sine, and we can plug in these values. Sine at pi minus the sine at 0. Okay, sine at pi is 0, sine at 0 is 0, so I'm getting 0. Okay, and what that means is, if you look, the antiderivative here this integral should represent the net change of sine over 0 to pi. So when I draw sine on the interval 0 to pi, I hope you can see that the y values, there's no net change. We started at 0, we end at 0. Okay, and that's that idea of what that net change means. Alrighty, just wanted to put that out there.